And now we're going to look at some nonlinear examples. So the first example I have here is a parabola, a quadratic equation. So quadratic equation, anytime we have the x squared function, this is going to produce what we call a parabola. And we need to plot at least 5 points for a parabola. So in this case, again, we can pick to be symmetric. If we want to be symmetric, we can pick -2, -1, 0, 1, and 2. You could pick 0, 1, 2, 3, and 4. That's fine. Just make sure that you pick at least 5 points, and then once you actually start to plot them, make sure that you have enough to get what shape you were supposed to get, which is a parabola. If you don't get the full shape, then you need to plot some more points so that you can get it. So in this case, if we wanted to graph our points, we would plug in -2. So we would get -2 squared plus 2. So that ends up being 4 plus 2, which is 6. If we plug in -1, we get -1 squared plus 2, which is going to be 1 plus 2, which is 3. If we plug in 0, we get 0 squared plus 2, which is just 2. If we plug in 1, you'll start to notice that this ends up being symmetric because we get 1 squared plus 2, which is 1 plus 2, or 3. And if you plug in 2, you end up with 2 squared plus 2, which is again 4 plus 2, or 6. So this is symmetric, and so this is going to produce what we call our parabola. So if we draw in our axis, notice that all the y values are positive here, so I'm going to do what I said that we can do with this graph paper, which is to put our axis down here on the bottom. We only have positive y values, so we don't really need to draw any of the negative ones. We can put the x-axis all the way on the bottom. Now, in this case, when we go to make sure we label things, again, this is going to be 1, this is -1, and then the height here for each unit will be 1. You can pick something else if you want to. So in this case, if we plot -2, we go to the left 2 and then up 6. We go -1 and then up 3. We go at 0, so the axis, we only go up 2. At 1, we hit that 3 point again, and at 2, we hit the 6 point. And we get this kind of U-shaped figure, which is what we call a parabola. The thing to make sure when you're plotting any of these is that you always go through and past the point, and you put those arrows on, because this graph is going to go on forever in both directions. So we want to make sure that we signify that by saying this is going beyond just the points that we plotted, with this arrow saying that it's going to go on forever. So again, the shape of the parabola is that U shape, and not on the next page, but on the page after that, you can see a library of function which shows you the basic shapes for a lot of common functions. So let's do another example of a parabola. Pause the video here, try this example, and then resume the video when you have the answer. So for this example, I picked, again, the same points that we had before, the same x values as we had before, and that was -2, -1, 0, 1, and 2. If you plug those into the equation given, you should get the values 19, 10, 5, 4, and 7. If you look at the graph, notice again, I put the x-axis all the way on the bottom because all of my y values were positive, and since all of them were positive, then I know to put the x-axis all the way on the bottom. The other reason I did this is because we have a rather high value here at 19, and because of this, we want to make sure that we have enough room as we can to get up to that point. So in addition to drawing the x-axis down here all the way on the bottom of the graph, I am also going to make this a unit of 2 to make sure that we can fit that 19 on our graph. I'm going to keep the x-axis the same as 1 and -1, but the y-axis is going to be in increments of 2. So if we plot these points now, I go back to the left -2, and then I got to go up to 19, but remember each one of these is 2. So 2, 4, 6, 8, 10, 12, 14, 16, 18, and then halfway in between would be 19. If we had not made these increments by 2, that would not fit on the graph. If we go to -1 and then 10, so 2, 4, 6, 8, 10. At 0, we are at 5, so 2, 4, and then halfway up will be 5. At 1 we're at 4, so 2, 4, and at 2 we are at 7, so 2, 4, 6, and 7. So this isn't quite as easy to see exactly where the low point is, but we do know that we've got a parabola that looks something like this. And again, this is why you want to make sure you continue the graph. We know it's got to be symmetric. It's got to match up with that other side. Another type of graph that shows up is that of a cubic. So anytime we've got a cubic function or a cubed as our highest exponent, we get a shape that kind of looks like an S. And again, you can see that on the next page in the library of functions. So a cubic function, we need to plot at least 7 points to make sure that we've got the whole thing. And it's possible that we might need to pick more. So again, I'm just going to pick symmetric. We'll pick -3, -2, -1, 0, 1, 2, and 3. And so if we plug those in here, we've got y equals -3. And if we plug that in, we get -3 cubed. And make sure you put these in parentheses so that you're either cubing or squaring the whole value. And you plug that in. Now, I'm going to pull up the calculator in here and try to show you kind of a shortcut for this. You don't have to plug in all of these values the whole time. And you do that by using what's called the table function in your calculator, but first thing you do is you hit y equals and you put in your equation. So in this case we have x, and then we use the caret button to get cubed, plus 5x, and then we've got a squared button, minus x, and plus 2. So we've got the equation in there exactly how we see it. And then the next thing you want to go to is you want to go hit second, and then this button that says table set. And the thing that you want to change on here is to scroll down. So you hit down until you're on independent, and you want to scroll over to ask, because you want to be able to put in the values that you want as far as these x values go. So if you go down here to independent, select ask, then you can go over here to table, and you'll get this blank table of x and y1. So now we can hit -3 and hit enter, and it'll give us that value of 23, which would be, you have that -3 squared, which is -27. Then you've got this -3 squared, which is 9 times 5 is 45, so you got a plus 45. And then you got a -3, which is +3, and a +2. -27 and 45 comes out to be 18, plus 3 is 21, plus 2 is 23. So this does work out to be the same as we get here. And then we can just plug in the rest of our values. So we can hit -2, and we can get that. It is 16, -1 is 7, 0 should be 2, yeah, because that's the only value that doesn't have an x. 1, 2, and 3. So now we have all of our values here, which are 23, 16, 7, 2, 7, 28, and 31. So that's kind of a shortcut. It also keeps us from producing as many errors if we use that. And again, it only works if you've got a graphing calculator or a calculator that can produce tables. So again, I'm looking at this function and I'm seeing that all of the y values are positive. So I'm going to place my x-axis down here on the bottom. I'll put the y-axis in the middle because we made it symmetric with all of those values. And now we go to say, okay, we've got values of 23, 28, 31, so we need to pick what increments we want to go by in our y-axis. I think we can get away with going by 3s if we do that way, and then down here this would be -1 and 1, so those will still be okay. So if we go back to -3 and go up to 23, so 3, 6, 9, 12, 15, 18, 21, and then kind of 2/3 of the way up here is going to be 23. Then we have 16, so we go back to -2, and then we go up to 16, so 3, 6, 9, 12, 15, and then a third of the way up will be 16. At -1, we're at 7, so 3, 6, and again a third of the way. At 0, we are at 2, so that's right here. At 1, we're at 7, so that was that same point that we had here. At 2, we are at 28, so 3, 6, 9, 12, 15, 18, 21, 24, 27, and then one more is going to be 28. And then at 3, we're at 31. So if this was 27, 30, 31. It's not real easy to see exactly what's going on here if we just kind of connect the dots that we have. It looks something like this. And like I said, with these, we know we have to have what's called an S shape. Now it looks like it's kind of starting to change directions and maybe go back down on this positive direction. So let's put in a few more points this way, 4 and 5, and see if that helps. So if I put in 4, I get 142, wow. And if I put in 5, I get 247, so that's not necessarily helping me get any smaller here. Let me check to make sure that was supposed to actually be, oh, 71, that's the issue. So you got to be careful on what you write down here. This was supposed to be 71, so this point is actually incorrect. So this is 71, which is not actually going to be on our graph, so we're not going to worry about that one. So let's go backwards a little bit further. Let's go back to -4 and -5. So if we put in -4, we get 22. That's not bad. And if we put in -5, we get 7. So we get 22 and 7 as our other points. So we go back here to -4. We go up to 22. So 3, 6, 9, 12, 15, 18, 21, 22. And at -5, we're back at that 7 value that we had. So this comes back down here and is going to cross. And this is going to go on up here forever. So like I said, I made a mistake there, so be careful when you're doing these that you don't make mistakes. You write down everything correctly. And in this case, like I said, 371 was not going to be on our graph, so we didn't worry about plotting that point. We needed to go backwards because a cubic function always has this kind of S shape, like I said. So it kind of goes up and then down and then up, or it can go down and then up and then down. But regardless, it has this kind of S shape. And since we knew we had to get some more points because we were only kind of seeing this middle parabola, we extended the graph by plotting -4, -5. So we had a few extra points in this. We ended up with 8 points that we plotted, but we got the full picture. And sometimes you have to do that. Just because you pick 7 points doesn't mean they're all going to show up and give you the full picture. So sometimes you have to expand your window, expand your options for your inputs. We've got one final graph here that I want to discuss, and that is of a square root. So with the square root, you usually want to pick 3 or 4 points to plug in. So I'm going to pick -1, 0, 1, and 2. So if I plug those in, I get y of -1 is going to be the square root of 4 minus -1, which is the square root of 5. And we can find a decimal approximation by just plugging that in the calculator. It's a little bit easier to graph when we've got a decimal approximation, which is 2.23 or 24 if we round up. If we look at y of 0, we get the square root of 4 minus 0, which is just the square root of 4, which is 2. If we do y of 1, we get the square root of 4 minus 1, and that is just the square root of 3. Again, we can do a decimal approximation for that, which is about 1.73. And if we do the last one here, y of 2, we end up with the square root of 4 minus 2, which is the square root of 2, which is 1.41. I'm going to do one more value here, and I want it to be 5, just to kind of show you something when it comes to square roots. If you were to take the square root of 4 minus 5, that comes out to be the square root of -1, which is the imaginary unit I. We can't plot that on a real number axis, so we just say that this is kind of where the graph stops, and I'll kind of show you what that looks like. The thing to keep in mind is where this starts, and this would start when the square root is 0, so 4 minus 4. So we would want to pick the x value 4, so we would get the square root of 4 minus 4 equals the square root of 0, which is 0. So we can plot that point. We can't plot the point 5i on this type of graph. There are types of graph where we can plot imaginary numbers, just not this type. So, in this case, I'm going to put the axis in here since that's the line that doesn't really want to show up for me. And then I will put in my y-axis. And I'm just going to do increments of 1. So, these are each 1, and these are each 1. So, if we plot these points, we said -1 was at 2.24, so 1, 2, and about a quarter. At 0, we are at 2. At 1, we are at 1.73, so 1 and about 3/4. At 2, we are at 1.4. And at 4, we are at 0. So at 4, we are here. And so this is what the graph for a square root function kind of looks like. It actually kind of looks like half of a parabola that is kind of flipped on its side. So the only thing left for this lesson is to kind of talk real briefly about the library of functions, which are listed on the next page in your notes. And if you look at these are just some common functions and the shapes, the general shapes that they take. The first one being the constant function, meaning we have something like f of x equals a number. And in this case, we have f of x is equal to 1, so we just have a straight horizontal line. It has a slope of 0. If we kind of increase that by 1 degree, we get the identity function, which is f of x equals x. And in that case, we just have a straight diagonal line that goes through the origin, has a slope of 1, so it's at a 45-degree angle. And that's just the basic identity function. We can improve on that by increasing this to be slope-intercept form, mx plus b, meaning we change how fast it rises over run and where it crosses the y-axis. In this case, we have the function 2x plus 1, so we cross here at 1. And then we have a slope of 2, so we would rise 2 and run 1. A little more involved are those functions that we just talked about, the square function, which gives you a parabola, the cube function, which gives you what's just called a cubic function, that kind of S shape. And then this one we didn't get a chance to talk about, and that is the reciprocal function, meaning you have 1 over x, and that produces this graph that kind of goes off to infinity in certain directions, and that's because you're dividing by 0 here at the axis, and to divide by 0 means that we get some numbers that get really, really big, but negative in the negative direction. We also talked about a square root function, which you can see here, and again, this just kind of looks like a parabola on its side, but only half of it. Cube root function is nice because we can get negative values out of it. So in this case, the cube root ends up having this tail. It kind of looks like a cube function put on its side. And then the absolute value function, which is just taking that y equals x function that we had, but flipping this negative part over because all of the negative values become positive. So that's just kind of a recap of some of the more common functions that you'll see. Obviously, you can adapt these given bigger slopes or coefficients in front of the leading term, but essentially these are the basic shapes that you see for most graphs. So at this point, this concludes the video for 4.2. Please go on and complete the homework for 4.2 and then the quiz for Chapter 4.